All right, this is your last week of videos and tasks, and I'm sorry to start out with notes, but I just want to go through these. So they're similar to notes we had from last week tasks. And number one basically says it's best to work on only one side of the identity. And so when we say that, we make sure that we are just changing one side into terms of sine and cosine. That's the easiest way to verify identities. And we do that because it may not actually match with the other. Like it might not actually be an identity. And then step two is we pick the side that is the more complex side, as it's easier to reduce or simplify than to build. Step three is something we haven't done yet, and it's basically saying if I was adding two fractions, I need to find a common denominator. That's all step three is saying. Now that can be kind of difficult when we're dealing with a denominator that has like sine or cosine in it, but we'll have one that we look at today, one or two that we didn't get to in last week's identities. This week they're just a little bit more involved. And step four is that converting all functions to sines and cosines. And then general algebra skills, thinking about, do we need to distribute? Do we need to factor out? We're going to be looking at multiplying by a conjugate this time. And then knowing all your Pythagorean identities inside out, upside down, and backwards. Those are your keys. Okay. So we need to look at verifying identity, and we talk about verifying an identity working on the more complicated side, and usually we talk about terms, but this both has two terms on either side. But the side that has the tangent squared minus sine squared, that's your more complicated side because it's separated by subtraction, and it's easier to take subtraction to multiplication than this side to go from multiplication to subtraction. So we're going to start on the right side this time. So I'm going to leave sine squared theta, tangent squared theta like this. First thing I'm going to do is I'm going to take tangent squared and write it in terms of sine and cosine. So that's sine squared theta divided by cosine squared theta minus sine squared theta. This does not look any better, but I'm going to go ahead and work on getting a common denominator for both of these so I can combine them. And in this case, I would need to multiply top and bottom by cosine squared theta. So our left side of our identity stays the same, but now we're going to get sine squared theta all over cosine squared theta minus sine squared theta cosine squared theta all over cosine squared theta. Now, because I now have the same common denominator, I can combine all of this into one fraction. So sine squared theta minus sine squared theta cosine squared theta all over cosine squared theta. Now I want you to stop and think, what could I do to simplify this more out of like my possible algebra strategies? I don't need to distribute. Could I factor? I've already used the finding the common denominator. There's no conjugate, which you guys might have forgotten what that is. So at this point I would say, look, I have sine squared in both of these terms, so maybe it's helpful if I factor. So I'm going to factor out sine squared theta. That's the greatest common factor. And then I'm left with 1 minus cosine squared theta all over cosine squared theta. And now I'm almost there. I know maybe you don't see it, but I'm almost there. So right here, this 1 minus cosine squared theta, we're going to deal with that last. But sine squared over cosine squared gives me that tangent squared. I'm going to write it in the second position just so it's similar to my identity up here. Now, can you see how I could maybe simplify this to sine squared? Because I know sine squared theta plus cosine squared theta equals 1, then 1 minus cosine squared must equal sine squared. So if I had subtracted cosine squared from both sides, I can see that these are equal. And so now for this point, I can just throw in the sine squared theta. All right. That was pretty involved. But we used a lot of different strategies. We used finding a common denominator, we used factoring, and then we used substitution, knowing our other Pythagorean identity. All right, let's show a couple more examples. Just with identities, the more you see, the better. The more you try on your own, the better as well. All right. So maybe pause and try to get this started. You haven't seen one exactly like this, but I want to see what you could do first with the strategies you know. So pick your side. The more complicated side is the left. Turn everything into sine and cosine. See how far you can get before you come back and we'll do it together. All right. So I'm going to leave this side alone. I'm only messing with this side. So this is going to be 1 over sine x in the numerator. And the denominator, cotangent, is cosine x all over sine x. And tangent is sine x all over cosine x because they're reciprocals of each other. And we want all of that to equal cosine x. All right, here, before I do anything else, I'm going to try to combine everything in this denominator by finding a common denominator. And my common denominator has to be sine x times cosine x because I need both parts of these in the denominator. So on this side, I'm going to multiply top and bottom by cosine x. And on this side, I'm going to multiply top and bottom by sine x. So I get 1 over sine x in the numerator. I'm not going to do anything with that yet. And then I get cosine squared x plus sine squared x all over the common denominator, cosine x sine x. I skipped a step in here. You could really say this is cosine squared x all over cosine x sine x plus sine squared x all over the same denominator. I just combined them all at once. Now, I want you guys to remember, what is cosine squared plus sine squared equal? So the Pythagorean identity says it just equals 1. So this simplifies to be 1 all over cosine x sine x. And now we need to remember how we divide fractions. We're going to take the reciprocal or flip the bottom fraction and multiply. So I'm going to come over here. 1 over sine x times cosine x sine x all over 1. And when I multiply that, these signs cancel out, leaving me with just cosine x, which is what I was trying to verify. I know there's a lot on that. You probably want to pause and make sure that you take notes. Maybe fill in like the actual process in your notes. So if you go back and look at later, you can be like, oh, Mrs. Ice did this because, so that you know. We're going to look at simplifying with a conjugate. So I'm going to start with the left side on this, and I apologize, I must be getting a delivery, so you get to hear Kane in the background alerting all of us that the postman is here, and he just thinks he's super scary. So the conjugate, if you remember, if I have 1 minus cosine of theta, the best way to get something out of the denominator or do something with it is to multiply by the same numbers but opposite sign in the middle. That's what we mean by conjugate. This is the conjugate. So if I were to take this side, which is a little more complicated because it has 3 terms, and I have 1 minus cosine theta, then I want to multiply top and bottom by this conjugate. 1 plus cosine theta all over 1 plus cosine theta, and we want that to equal cosecant theta plus cotangent theta. So now I'm going to distribute sine to both of these. So I get sine theta plus sine theta cosine theta. And what happens when I multiply by the conjugate? If I distribute all my terms, 1 times 1 is just 1. But I'm going to get plus cosine minus cosine if I do the FOIL, outer and inner. Those are going to add to be 0. So then I'm going to skip that and have minus cosine times positive cosine is 1 minus cosine squared theta. And we want that to equal cosecant theta plus cotangent theta. Well, hopefully you know that this equals sine squared, because I know that sine squared theta plus cosine squared theta equals 1. And if I subtracted both sides by sine squared, or subtracted both sides of cosine squared, I would see that this whole thing here just equals sine squared. So I'm going to substitute that in. All right. And now I'm going to separate my fractions into 2 separate fractions because I have 2 separate terms here. So stick with me on this. This is going to be sine theta all over sine squared theta plus sine theta cosine theta all over sine squared theta. So this is like having x over x squared. And if I simplified that, that would be 1 over x. So this is going to be 1 over sine theta. Same here. I'm going to end up with cosine theta, because I can't simplify that, over sine theta. And hopefully you guys realize that this is cosecant theta, and this is cotangent theta. All right, that was a lot. I did have a couple extra examples I would have used during this, but I think I'm going to stop here, and if you guys need the extra examples, then you guys can let me know and I'll make another video and send it out to you.